Hi everyone, my name is Nghĩa. I'm studying at Vietnamese German University. I was the winner of June, but this time I want to challenge myself a little bit with this aircraft, the F-16, the most successful aircraft of the US Army and also my most favorite one. And today, this time, I will analyze the nose landing gear of this aircraft. Okay, let's check it out. Before optimizing it, we must understand how the landing gear works by doing some simulation, so let's get started. When the F-16 is in operation, there are several critical cases, for example, takeoff, approach, and landing. But in this case, I want to focus on the landing. And let's continue with the nose landing gear. I use the nose landing gear of the RC plane to analyze. This model looks similar to the real one and the mechanism is exactly the same. To make it move, we need to add some constraints such as row, rigid roots, and joints. Here is some of joints we have in this model. Then we add a motor to rotate the part. But this is not the most interesting part. We have to make it more real by adding some modification to this model. First, let's start with the shopper inside the cylinder that make the virtual brow. Here we split the cylinder and add the spring and damper between the gap. Then we add a table that can rotate as a landing ground. After that, we decrease the stiffness of the ground a little bit to make the deformation. Don't forget to add a contact point between the wheel and the rail. Then here we go. Looks like we have the perfect simulation. We already had an airport on our laptop. But motion is not just for fun. Actually, by doing a simulation, we can analyze force at the contact point is around 32 kilonewton. That means 20% of the maximum takeoff weight of this aircraft. And the most important thing is what happens to this joint. Here we have the force diagram depending on time, and we can see the force and also the moment in the XYZ direction. Based on that, we can easily know what is going on in this part. Let's take this main cylinder part for example. We insert the force and the moment that we already knew from the motion and reverse the direction. For the material, choose the titanium alloy and then run the analysis. We can see the movements of the model and then the safety factor, which is very important when we analyze parts from the aircraft. Then go to the optimization. I would like to choose the maximum stiffness and remain just 30% of the material, and also the step control. Let's wait. After that, we need to choose the cut section to see the inner part pattern, and maybe analyze it again to make sure it's safe. Well, it's quite safe, no worry about that. Based on that, I also optimized the outer part, cover it by polynerve and put it into the assembly. And let's compare the mass between the initial design and our design. Well, it reduced 44% of mass. That sounds crazy compared to the first one. And we also want to touch it. So let's print it with 3D printing. And here's how this nose landing gear part is produced. Well, I use SLA 3D printing for the best precision, which is good for motion. And in total, we have 16 parts. I already optimized 10 parts. Also, we do have some screw and rubber washer for assembly. And to make it easier to see, here I will list all the parts before and after the optimization. Now I will show you the simulation of this. Go back, and then front view, and then go back, and then top view, and then go back. We have perfect simulation, right? As an engineering student, I think one of the most happiest things is that you can turn the idea into a reality, that you can even touch it. And well, I never imagined that I could optimize the F-16 nose landing gear, one of the most complex aircraft structure, in just 5 minutes. And thanks to Altair, turned out it's super easy. And well, as a future engineering, I'm glad to say that the simpler you do, the smarter you are. And that's all. Goodbye and see you again.